Hello all, in this video lecture today we are going to discuss about the FIR filter designing using the Fourier series method. Okay, we have different types of designing methods of the FIR filters. We have a Fourier series method, we have window techniques, and we have frequency sampling method. Out of these three methods, now we are going to see in this video the Fourier series method. So without much delay, let us go into the problem. See, to solve the problem based upon the Fourier series method, we have to know the 4 steps, only 4 steps. If you know these 4 steps and 4 formulas, it will be very useful for you for designing the FIR filters problem using the Fourier series method if it comes in the examinations. Okay, the first one is designing the filter coefficient formula. The first one is designing the filter coefficient formula, and second one is the transfer function formula, and third one is the realizable transfer function formula, and fourth one is the frequency response formula. Only these 4 formulas only you have to remember while solving this Fourier series method. Not only this, the FIR filter design mostly depends upon this only. Okay, now let us go to the first problem. Let us design the FIR filters using the Fourier series method. So here the problem, the design of ideal low pass filter with a frequency response HD of e power j omega is equal to 1 for the omega is in between minus pi by 2 to pi by 2 and 0 for pi by 2 to pi. See, whenever the question gives, you have to see these ranges. This is the important tip when you are solving the questions. This will very useful for the students. As a student point of view, you have to see these ranges. If you see these ranges, if you observe these ranges, according to these ranges, if you are able to plot the frequency response graph, then it will be very useful for you for determining the filter coefficients. That's why you just pay concentration on this. Okay, now next, find the values of h of n for n is equal to 11. Find h of z and plot magnitude response. Finding the h of z is nothing but the finding the transfer function. Finding the transfer function is nothing but the designing of the filter. So now, according to this, let us go to the frequency response of the low pass filter. So he has given these specifications, right? When the omega is in between minus pi by 2 pi by 2, so HD of e power j omega means the frequency response is equal to 1. According to this, we are going to plot here. See, minus pi by 2 to pi by 2, the value is 1. HD of j power j omega on y axis we have taken, so it is equal to 1. When the 0, when the omega, this omega x-axis omega is in between minus pi by 2 pi by 2, or otherwise it is equal to 0, it shows. Next, now from the frequency response, we don't have any ripple, so the ripple factor alpha is equal to 0. That's why it is a non-causal. So the system is a non-causal filter coefficient. So about n is equal to 0. This is n is equal to 0. Therefore, HD of n is equal to HD of minus n. This concept is also very important because response of the filter coefficients of n is equal to HD of minus n. So the filter coefficients can be calculated by using the formula. So this is the important formula you have to remember. So HD of n is equal to 1 by 2 pi of integration of minus pi to pi HD of e power j omega into e power j omega n d omega. So you have to practice this formula before going to the examinations if you want to solve the Fourier series method. Okay, now this is the formula. Now according to our problem, this formula has been turned into 1 by 2 pi into integration of minus pi by 2 to pi by 2, because from the integration of minus pi by 2 to pi by 2 only this value is equal to 1. Otherwise this value is equal to 0. That's why our integrations is restricted to minus pi by 2 to pi by 2. This HD of omega, within this range, this HD of e power j omega is equal to 1 into the formula e power j omega n into d omega. Now if you apply integration to the e power j omega, the integration to the e power j omega is equal to 1 by jn into e power j omega n, when these are the lower limit minus upper limit. 2 by already there in the problem. So pi n I am taking it to this, and 2j I am writing like this. So if you apply limit minus lower limit, so e power j theta minus e power minus j theta by 2j according to that formula. So e power j pi n by 2 minus e power j pi n by 2 by 2j is turning into sin pi by 2n. So sin pi by 2n by pi n. So this is the filter coefficient you got. Okay, now this is the HD of n, but we have the n value is equal to 11 samples, right? So we have to truncate this HD of n value for n values. Actually these are the values for the n values minus infinite to plus infinite, right? But here in the problem we have given n is equal to 11, so we have to truncate this value to the 11 samples. So for truncating these values, we will write h of n is equal to sin pi by 2 by n by pi n when the modulus of n is less than or equal to 5. Truncating the value, because we know hd of n is equal to hd of minus n, so that's why if you truncate at 0, so at the left side we have 5 samples, at the right side we have 5 samples, so total is equal to 5. So next, and so this is equal to 0 otherwise. So this is the equation for our problem. Okay, now you have to substitute the n value. N value is less than or equal to 5, right? So we have to substitute the each and every value of n till 5, so that we have to find out the h of n. Okay, for finding the first value of h of n, if you substitute n is equal to 0 in this equation, you got here in the denominator you got n is equal to 0, so it is determined by, it is undefined value. So that's why we will not directly substitute the n value here. Okay, we are applying the limits according to the L hospital rules. We are applying the limits. So L hospital rule is a rule which is applied for the indeterminate conditions or undefined values. So according to that values, for n is equal to 0, I'm applying h of 0. If you substitute n is equal to 0 in this condition, h of 0 becomes limit n tends to 0 sin pi by 2 into n by pi n. So sin pi by 2 by n into pi n is equal to, see, at side limit n tends to 0 sin pi by 2 by n into pi n by 2. So because I know sin theta by theta is equal to 1, so I have to make it here in the denominator we have pi n only, I have to make it pi by 2n. So that's why to make it pi by 2n, I'm taking one more 1 by 2 here. So 1 by 2 into line limit n tends to infinity, sorry, 0 sin pi by 2 into n by pi n by 2. So now this is in sin theta by theta formula. Now this total term is equal to 1. So if it is 1, so we have left with 1 by 2. So h of 0 is equal to 1 by 2. So remember guys, in the actually to get the h of n values, we have to roll the n value from 0 to 5, so that we will get the values, right? But here for n is equal to 0 we cannot substitute back, because if you substitute n is equal to 0 in the denominator will be undefined conditions. In such cases, instead of substituting the n value directly, we will go for the L hospital rules. L hospital rule is giving you the values for the undefined conditions. Now for the first value only we will do that. From the next values, so we are substituting n is equal to 1, and for n is equal to 1, if you substitute n is equal to 1 in the h of n, so h of 1 is equal to h of minus 1 is equal to sin pi by 2. In place of n I'm substituting 1, pi by 2 into 1 by pi into 1, so is equal to pi. So sin pi by 2 by pi, so you will get the 0.3183 if you do the calculation in the calculator. Now similarly, h of 2 is equal to h of minus 2 is equal to sin pi by 2 pi is equal to 0. h of 3 is equal to h of minus 3 is equal to sin 3 pi by 2 by 3 pi, that is equal to minus 0.106. h of 4 and h of 5 also. So you have to find out till 5, because we have rolled truncated our values to till 5 only. Okay, because it is a non-causal sequence, so whatever the values at the positive side will be at the negative side. So the total out of 11, so 0 will be the middle one, and the positive side plus 5 and negative side plus 5. That's why h of 1 value is equal to h of minus 1, h of 2 value is equal to h of minus 2, h of 3 value is equal to h of minus 3, like that. So total 11 values. Okay, so like this we have found. Now after finding this, then we have to realize so this is the formula for deriving the transfer function. h of z is equal to h of 0 plus sigma n is equal to 0 to n minus 1 by 2 of h of n into z power n plus z power minus n. So this is the value we have found till now, h of n value, right? So now h of 0 value we have found is equal to 1 by 2. You just know that is equal to 0.5 plus 1 plus sigma n is equal to 1 to 5 h of n into z power n into z power minus n. So if you substitute n value 1 to 5, so h of 1 you will get z power 1 into z power 1. 2, if n is equal to 2, h of 2 into z power 2 into z power minus 2. 3 is equal to h of 3 into z power 3 into z power minus 3. Like that, we have substituted for z power minus 5. The equation is shown in here. Okay, this is the transfer function, but we have to find out the transfer function of the realizable filter. For that, the formula is h bar of z is equal to z power minus of n minus 1 by 2 into h of z. Okay, so the n is equal to 11, 11 minus 1, 10, 10 by 2 means 5. So total z power minus 5 is of h of z. H of z value we have derived just now here. So this is the h of z value. If you substitute h of z value, you will get this. This is the h of z value, you can note down. Okay, next is writing the equation. If you solve this, I'm writing the equation according to the order. So first constant, next z power minus 2, next z power minus 3, z power minus 5, z power minus 6, z power minus 8 and z power minus 10. So we don't, whatever the equation I got in the previous section, I'm just rearrange it according to the order. So now in the above equations, we can note that the filter coefficients are h of 0, h of 0 or h of 10. See here, h of 0 is this and h of 10 is this. Okay, see the coefficient 0.0636 and here also 0.0636. So h of 0 is equal to h of 10 is equal to 0.0636. Now see here, h of 2 0.106, right? Anything we got 0.16? Yes, 0.106. So h of 2 is equal to h of 8. So see the order minus 2, z power minus 2, second order, z power minus 8, h of 8. So like that, h of 2 is equal to h of 8 is equal to minus 0.106. And we don't get z power minus 1 value here. Z power minus 1 value is not there here. So h of 1 and h of 9 both are not there. So h of 1 and h of 9 is equal to 0. H of 3 and h of 7 is also equal to 0. Now h of 4, z power minus 1, 0.3183 and h of 6, z power 0.3183. So both are same. So h of 4 and h of 6 is equal to 0.3183 and h of 5 is equal to 0.5. So this is the way of realizing the filter. In the question, if they are asking you to simply find out the h of z, till here it is sufficient. Till here it is sufficient. We have find out the filter coefficient. We have find out the transfer function of the filter. Next, realizable transfer function of the filter also we have find out. Okay. Now, but in the problem they have asking you to plot the magnitude response. For plotting the magnitude response, you need to calculate. You need to find out the frequency response, right? So the frequency response is the formula given by, so h bar of e power j omega is equal to sigma n is equal to 0 to 5, because 5 is minus, actually here the formula is n minus 1 by 2. So n minus 1 by 2, 11 minus 1 by 2 is equal to 10. 10 by 2 is equal to 5. So n is equal to 0 to 5 a n into cos omega n. This is the formula. Now here we don't have a of 0. Now a of 0 formula is h of n minus 1 by 2 and a of 1 is 2 into a of n is 2 into h of n minus 1 by 2 minus n. Now a of 0, if you substitute h of n minus 1 by 2, so n is 11, 11 minus 1 is 10, 10 by 2 is 5, so h of 5. So h of 5 value, how much we got here? 0.5, right? H of 5 value 0.5. I'm substituting here. Now the formula for a of n is equal to 2 into h of n minus 1 by 2 minus n. So in this you will substitute a of 1. If you substitute n value, if you substitute 2 into 5 minus 1 by 2 minus 1, you will get 2 into h of 4. 2 into h of 4 means h of 4 we got already 0.3183. 2 into h of 4 you will get the value 0.636. Guys, I think you understand. Similarly, a of 2 value I found out, find out, a of 3 value I find out, a of 4 value, a of 5 value also I did. You can note down here. A of 0 values, if you substitute that all a of 0 values in this equation, 0, for example, a0 into cos 0 omega, a1 into cos omega 1, a2 into cos omega 2, a3 into cos omega 3. Like that, if you substitute, you will get h of e power j omega is equal to a0 means 0.5 plus a1 means 0.63666 into cos omega minus 0.212 into cos 3 omega plus 0.127 into cos 5 omega. This is the frequency response equation. But they are not asking you to find out the frequency response. They are asking you to plot the magnitude response. To plot the magnitude response, we have to take 20 log h of e power j omega, this omega you have to take. After that, you have to roll the omega values. See, here I have taken z 0, 10, 20, 30, 40, 50, 60 like that. So instead of 10, you can take 0, 25, 50, 100, 150 also you can take. But I have taken like this. So if omega is equal to 0, here you have to substitute 0.5 into 0.5 plus 0.636 into cos 0 minus 0.212 into cos 3 into 0 plus 0.127 into cos 5 into 0. Like that, if you substitute, you will find the value of h of e power j omega. After that, if you calculate 20 log of that value, you will get this value. Like that, take the values, then you just plot the plot like this. You will get the plot like this. You can note down the values and you can check with the calculator. And if you plot this value, this will be the plot. You can plot it. Okay.